In this video, we learned how to integrate using the U-Substitution method, and as we can see in this example, the first step that we need to decide is what to take U as, such that the derivative of U cancels out something in the integral. So we can see that we have in the brackets x squared plus 3, so let's take U to be x squared plus 3, and the derivative of if we derive both sides, we'll get du is equal to 2x dx, and once we rewrite this, we will get dx is equal to du over 2x, and we can notice that we can use this to cancel out the 4x over here, so that will work out. Now let's say if we took 4x as u, so u is equal to 4x, and then du is equal to 4 dx, and then it will be equal to dx is equal to du over 4, and we can see that even though we have a 4 here, it won't cancel out this x. The x will be still it will be left over, and we will get stuck then. So of course we need to take u as x squared plus 3, and now let's rewrite this. So equal to 4x, and now we wrote this as u now, so we have to do u cubed, and then dx, we need to replace it with this part over here, so du over 2x. And now we can cancel out 2x with 4x over here, and this becomes 2. We can take 2 out now, so integral of 2 outside, and then this is u cubed du, and now we can just basically integrate this now normally, so we'll get u4 over 4 plus c. And now the final step that we always need to do is to replace u with what we replaced in the beginning. So first of all, we can just cancel out this, simplify this, so there's only half left now, 1 over 2, and then u is x squared plus 3 cubed, not cubed, to the power of 4 plus c. So this is the final answer. So in our next example, we have integration of x to the power of 3 e to the power of x to the power of 4. So whenever we have e which is to the power of x, and this number, the exponent of x is not 1 and more than 1, let's say x to the power of 4, so it's not 1, we always take the exponent as your u. So whenever n is more than actually not equal to 1, so let's take u to be x4, and then du is going to be 4x3 dx dx here is going to be then du over 4x3, and now we can substitute, go back to the original equation. So integration of x3 e to the power of u, and dx is du over 4x3. Now can this cancel out with this, and simplifying this more, it's going to be 1 over 4 outside, eu du, and the integration of eu is just simply eu plus c, and don't forget to substitute back u as the original value, which is x4, so equal to 1 over 4 e to the power of x4 plus c. So in our next example, as we can see, we have integration of 8x square root of 40 minus 2x squared dx, and the first step that makes it easy for me is to get rid of the square root and just rewrite it as brackets to the power of half. So what I mean is 8x and 40 minus 2x squared to the power of half. And now we can see that we can take the brackets as u, and the derivative of 2x squared is going to be 4x, and we can use that to cancel out this part. So let's do that now. So u is equal to 40 minus 2x squared, and then du is equal to minus 4x dx, and we can rewrite this as dx is equal to du over minus 4x. And now we can go back to the original formula equation and substitute what we have, u to the power of half, and dx is this part over here, so du over minus 4x, this can cancel out with this, we're left with 2 here, and we can bring the minus 2 over there also, and we're left with minus 2 integration of u to the power of half du. And now just integrate this normally, so we will get u 3 over 2 over 3 over 2, which we can bring up, and will be just times 2 again, and the final answer will be minus 4 over 3 u. I'm going to substitute back what it was, so open brackets 40 minus 2x squared to the power of 3 over 2. And we can never forget the c, the constant c. So in our next example, what do you think the u should be? And please try to pause the video and try to solve the question on your own. So we normally always take whatever is in the brackets, and we can see that we have a x4, x to the power of 4, and we have a x cubed up there. So we know that the derivative of x to the power of 4 is going to be 4x3, and that x to the power of 3 is going to cancel out the numerator. So let's take u as 2 plus x to the power of 4, and du is going to be then 4x3 dx. dx is going to be du over 4x3. And now let's go back to the original equation. So x3 over u to the power of 2 times du over 4x3. x3 can cancel out with this, and we can take 1 over outside now. Integration of 1 over u squared du. And now we can bring this u squared up, so it will be 1 over 4 integration of u negative 2 du. And now we can just integrate this normally, so we'll get 1 over 4 outside, and we will get u to the power of negative 1 over negative 1 plus c, and simplifying this more now, so it's going to be negative 1 over 4 times 1 over u, and we can substitute u as the original value, so it's going to be 2 plus x to the power of 4 plus c. So this is the final answer now. So what do you think we should take u in this question to be? Since we need to get rid of at least one of these elements, so we need to take u such that the derivative of the u cancels out one of them. So let's say if we take u to be cosine, the derivative of cosine is negative sine, and we will still be left with sine to the power of 2, which is not possible to integrate. And if we take u to be sine x, the derivative of sine is cosine, and that will cancel out one of the elements, and we will be left with u squared. So let's do that then. So u is sine x, du is going to be cosine x dx, and again dx is equal to du over cosine x. And now let's go back to the original thing. So it's going to be u to the power of 3, since we replaced sine x with u, and cosine x, and now we write du over cosine x. So this cancels out with this. We are only left with now integration of u cubed to du, and this is equal to u4 over 4 plus c, and just replace u as the original thing. So it's going to be sine 4x over 4 plus c. So let's move on to another example. So this is a more complicated example. So you can pause the video and try to do this yourself. I highly suggest that. So let's take the inner sides of the brackets as u as usual. So u is going to be equal to 3x plus 2, and du is equal to 3 dx. And if we isolate dx is going to be du over 3. And one thing that you can notice is that the power of x here is 1, and the power of 3x is also 1. So we are not able to cancel out this x over here this time. And whenever the powers are the same, we go to our first equation, which is this one, and we isolate x. So basically we solve for x in terms of u. So if we do that, I'm going to bring it down. Yes, so u is equal to 3x plus 2. We can bring the 2 to the other side, so u minus 2 is equal to 3x, and now we can bring the 3 to the other side, divide both sides by 3. So u minus 2 over 3 is equal to x. So we substitute x as this part over here, this x, and this as u, and let's do that now. So it is equal to integration of u minus 2 over 3, which is equal to x, as we solved for x here, and now open brackets u to the power of half, and dx over here is du divided by 3. So I'm just going to take the 3 outside here, 1 over 3 du. And now what we can do is we can bring this 3 outside, 1 over 3, and this 1 over 3 outside. So it's going to be 1 over 9 integration of u minus 2 into u to the power of half du. And we can simplify this more by just multiplying u by u here and minus 2. So let's do that. Oops. Yeah, so equal to 1 over 9 integration of u 3 over 2. Since this power is 1, and we just add half to the power of half, and the other one is 2 u to the power of half du. And now we just integrate this, so I'm going to make more space. So it is equal to 1 over 9 integration is going to be open brackets u v plus 1, so it's going to be 5 over 2 over 5, and I'm going to bring the 2 directly up, because once this goes down you can bring it up. So I'm going to make it the numerator, minus 2u, and here is going to be 3 over 2 over 3 over 2. So again I'm going to just bring it up here and multiply it. So 2 times 2 is 4. And we close the brackets and plus c. And now we can simplify this more. So it's going to be, so simplifying this more, it's going to be 2 u to the power of 5 over 2 over 9 times 5, which is 45, minus 1 times 4 is going to be 4 u 3 over 2 over 9 times 3, which is 27, plus c. And now the final step left is just substituting back what is u. So that is equal to, so it is equal to 2 over 45 open brackets, u was, let me just scroll up, 3x plus 2. So 3x plus 2, close brackets, 5 over 2 minus 4 over 27. Again, u is 3x plus 2 to the power of 3 over 2 plus c. And that is the final answer. So this example is quite similar to the last one, so you can pause and try to do it yourself. So let's take u to be the inside of the square root, and again I like to just remove the square root and replace it with to the power of half. This makes easier for me. I don't know about you guys, but yeah. So u is 4x minus 5, and du is going to be 4 dx, and dx then is going to be du over 4. And once again we notice that the power of x here is 1 and this is 1, so we need to solve for x in the first equation, which is this one. So it is going to be u plus 5 is equal to 4x, and then x is going to be equal to u plus 5 over 4. So let's start substituting stuff here. So it is going to be integral of 2, and now we replace x with u plus 5 over 4, and we can take the 1 over 4 outside, so I'm just going to do that to make it more simpler. 1 over 4 into u plus 5, close brackets and then open brackets again. 4x plus 5 is also u to the power of half, and dx, as mentioned over here, is du times 4. So I'm just going to write 1 over 4 du. So now to make it more simpler, we can take all the non-u terms outside, which is 2 times 1 over 4 times 1 over 4. So that is equal to, this is half, and then half times 4. 1 over 4 is going to be 1 over 8. So equal to 1 over 8 integration of u plus 5 into u to the power of half. And now we can simplify this more, and this is equal to 1 over 8 integration of u to the power of 3 over 2 plus 5u to the power of half du. And now we can simply integrate this like we do. So 1 over 8, and u is going to be u plus 2 over 2, so it's going to be 5 over 2 over 5 over 2, so it's going to bring it up 2, and then the other one is 5u3 over 2 over 3 over 2, so multiply 5 by 2 and get 10, close brackets, plus c. And now we can simplify this further, and we will get, so you're gonna get 2 over 40 u to the power of 5 over 2 plus, this is going to be 1 times 10, so 10 u3 over 2 over 3 times 8, or 8 times 3, which is 24, plus c. And we can further simplify this now, so we're going to get 1 over 20, and we can also replace u as the original value, which was u was equal to 4x minus 5, and here I'm just going to write that, what was it, yeah, this one. Okay, so 4x minus 5 to the power of 5 over 2 plus, this is going to be simplified to 5 over 12, yeah, so 5 over 12, u again is 4x minus 5 to the power of 3 over 2 plus c. So this is the final answer. Now there is a shortcut method on the calculator where you can simply just type your original value, original integral, with two random numbers, and you can recheck your final answer by substituting those same two random numbers. And I will be making a short video on that, how to do that. And yeah, so stay tuned, and I'll see you for next time. Thanks for watching.